In this video, we take a look at the line and see how these three forms of the line, which you might be familiar with, are all related to one another. First, we're going to start off by looking at the graph. So the graph of a line shows you the picture or the shape of what a line looks like, which generally makes sense, but I do need to point out one thing. When you were younger, this counted as a line. If we said draw a line connecting points A to points B, that could be a line, this could be a line, but when we get to math and algebra, a line has to be ruler straight, as in you could draw it with a ruler, there are no bumps, no curves. So that's the picture of a line. Now on the graph, there are a few aspects of the line that we want to look at. One of them is the y-intercept. Now that's just the number where your line meets or intersects with your y-axis. So in this case, it meets at the number 1, so the number 1 is the y-intercept. But the line is more than just a shape on your graph. It's more than just a series of terms. It actually contains a whole lot of data, and it's data about how these two different variables are related. So what do I mean by that? Well, I need to introduce you to this concept of an input or output machine. A line is actually called a function. Don't let that scare you. A function is just something where, again, we've got a machine where you put in a certain number and it spits out another number. So think of like, I don't know, a machine that if you put in, like a bread maker, if you put in ingredients for bread, it pops out a loaf of bread at the end. But we're dealing with numbers. Let's take a look here. These are our x numbers here. So I'm going to point out one point on the line and we'll talk about what this information tells us. Well, the coordinate for this line would be 1 because we start with the x's, and the y coordinate would be 4. Now what that tells us is that if I put in a value of 1, here's our input, that our machine is going to spit out this output number y4. I could take a look at this point here, and this coordinate would be 2, comma, let's see, so that's a 2, that's a 7. So this is now telling me that if I put in an input of 2, my output is going to spit out as 7. So put in a 2, out comes a 7. I can do that with this point here as well. This is a 3, comma 10. Let me go a little bit faster. And hopefully what you see is you put in a 3 and out comes a 10. Now there is one point that I kind of ignored because it was a little bit harder to see in the moment. Our y-intercept is 0, comma 1. What that tells me is that if I put in an input of 0, what comes out is a 1. So put in a 0, maybe I'll sneak it in up here, put in a 0, and what comes out is a 1. So I hope you're starting to see that what this line holds is a ton of information about how these two things are related. And these two things could be, for example, how many hours you study versus your grade. But any dot on this line gives you how those two things are related. Now we can take that a step further, and instead of displaying our information this way, I could put all this information in a table of values. So I'm going to go ahead and take our numbers from that machine picture and write it here. I'll color code it for you too. So we said when a 0 goes in, out comes a 1. And then we said when a 1 goes in, out comes a 4. Then we said when a 2 goes in, out comes a 7. And when a 3 goes in, out comes a 10. So that's how this table of values and this graph are related. Now, often you've been given a table of values and you've been asked to plot the line, and that works as well because the relationship goes both ways. So if you're given a table of values, you can then take these points, and remember each of these points gives you one coordinate. You can then use that to plot your points and connect them with a straight line. So that's how you go from table of values to graph, but we've just seen how you can go from graph to table of values as well. Now, wouldn't it be nice if we could figure out what the rule was over here? if we could figure out what it was that this computer, this machine was using to transform a 1 into a 4, a 2 and a 7, and so on and so forth. Well, that's where the equation of the line comes in. Now, any equation of any line can fit into this form called slope y-intercept form, or y equals mx plus b. Now, the important things to know about this form is that m and b are really just placeholders. They're placeholders until we figure out what the actual number should be. So the number that sits in this spot is what we call the slope of the line. Now, the slope of the line, you might remember, has a couple formulas. It has rise over run, or we can also have the formula y2 minus y1 over x2 minus x1. B is a placeholder for whatever the y-intercept is. Now, our y-intercept, we can see it from our graph, and over here it's a 1, so in this specific line, our b value would actually be a 1. So what does that mean? That means if we can find a number for our slope and a number for our y-intercept, we can just replace these m and b letters with the actual numbers for our line. So let's try that for our line. Now, we've already seen that our y-intercept is 1, so I'm going to go ahead and down here I'm going to say my b value is going to be a 1. I'm going to use this in a little bit. We do have to find our slope as well. So to find our slope when you're given a graph, I like to choose 2 points that are easy to read. Maybe I'll choose this one and this one. And in one of my previous videos, I said it's as though you're walking a path from point A to point B, and you always go from left to right. Okay, so imagine you have a person. Now, they can't walk along the diagonal, so they have to go up and over, or you could go over and up. But either way, if you're walking up, your rise is positive. If you're walking to the right, your run is positive. So just like on a number line, positive, positive versus negative, and down would be negative. So using this, I can see that my rise went from 1 to 4. So my rise is going to be a positive 3. And my run is going to be from 0 to 1. It's only 1 unit for my run. So bringing it back to my formula, this is going to be a rise of positive 3, a run of 1, and when I reduce that, I get this. My m is 3. So again, what this means for our equation, let me just copy this out, is remember that the m and the b were just placeholders for the actual numbers. So now that I have an actual number for m, I can take this 3 and put it in front of the x. And now that I have an actual number for b, I can take this value for b and put it in its spot here. So this is now the equation of our line. Well, how does that relate to everything we've talked about? That kind of ties everything together. I'm going to take our equation and write it in here. Now that becomes the formula that our machine uses to compute what the outputs are. So let's take a look. For example, if I have an x value of 0, what the calculator in this machine does is it replaces the x with a 0, it does BEDMAS, and it gets you your output of 1. And you can try that with any of the others, and you'll find the same thing. Let's say I take this one now. How do I get my 4? Well, the calculator in my function says let's do 3 times 1 plus 1, and that gets you your 4. So the equation of a line is really what we use to generate the points that go into this table of values. So I'll say that again. This equation is what we can use to generate these coordinates here. So I'll say if I choose to put in a 0, an output of 1 comes out. Then I choose to put an input of 1, an output of 4 comes out. Now that line, or the equation of that line, is also very much related to its own graph as well. Because what this graph shows is an even more complete picture of input and outputs in this table of values. This table of values only shows us inputs and outputs for a finite number of inputs and outputs. However, this line can really give us everything. On this line, I could say, well, if my input was 4, what would my output be? It shows us everything, but it might not be as accurate as we want. So let's say we want to figure out if my input is 3.5, what would my output be? Well, now it's a little bit harder to see because we're a bit restricted by the graph itself, by the scale, and by limited space. So the nice thing about your equation is your equation can generate any point you want on this graph, any point you want on this table of values. So for example, let's say I take that example of 3.5 again. I would like to figure out what the output is at 3.5. Well, how would I go about doing that? Remember that your input that you're choosing is an x value. So really what I'm looking at right now is I'm saying, let's erase some of this. What I'm trying to figure out now is if I put an input of 3.5, what comes out the other end? Well, remember, we're going to use our equation, replace the x with our input of 3.5. If you put that into your calculator, you get 10.5. And then we get 11.5. So that tells us that what should come out is 11.5. In my table of values, I'm going to replace that with 11.5. And let's see how accurate our diagram is. Yep, that's about 11.5 because this will be your 11 and this will be your 12. So from the equation, we can generate the x and y coordinates that we would find in a table. And we could also generate the x and y coordinates that we would find if we had plotted it on a graph. Okay, so I'm just going to copy this and duplicate it and bring it over here so you can see what I mean. Well, let's go even deeper now. I want us to look at this question. Is the point 414 on our line? How could we answer that question? Well, I could take a look at my table of values and look to see if I had 414 in my table of values. I don't, so that's not super helpful. I could take a look at my graph and say, okay, this is point 4, comma, and over here it looks like it's just going to be a 13. So no, 414 is not going to be on my graph because 414 is here, therefore it's not on the graph. That's easy enough when I can see the graph. What happens if the point in question isn't found on my graph? So what happens if I change this now to is the point 7, 20 on our line? How are we going to figure that out? So if you've been following up until now, I would challenge you to pause the video here and see if you can figure out which of these you could use to answer this question. And once you figured out which one to use, then think about how you could use that. Okay, so hopefully you've had some thoughts, even if it's just ruling things out. So by process of elimination, I can't figure it out using the table of values. I don't see a 7 here to compare it to figure out whether that's actually a 20. I can't use my graph either because it only goes up to 5. So really that just leaves me with my equation. So how can I figure out if this point is on the line? It all comes down to the whole function is a machine, or the line is a machine, the equation is a machine. I want to figure out if I put in, if I put in a 7, will a 20 come out? So again, how do I figure out whether that's true? It would only be true if that fits our equation. So let's test that out. We are going to replace x with the number 7, or sometimes we say sub x equals 7 into my equation. So y equals 3 times x plus 1, 3 times 7 plus 1, that gives me 21 plus 1, and that gives me 22. So no, the picture should look like this. If I put in a 7, what comes out the other end should be a 22, not just a 20. So that's how we can find that, well, if we had put it in the table, I'd have a 7 and a 22. If I had it on my graph, it'd be 7, and my point would be 7, 22. And so we can confidently say, is this point on our line? No, it's not. That point should have been 722 for it to be on our line. So I'm hoping that this video gives you some sense of how these three things are now related. That way, when we start to do more with the line, we can come back to this relationship and see why we might be using the equation, for example, to figure things out about the graph and vice versa. Hope that helped. Thanks for watching.
For a copy of the full cleaned up mind map, please see the link in the description below. If you found this video helpful, please like and subscribe.